Good morning, everyone. In this meeting, we will be learning about atoms. Here's an example of the atomic structure. It is made out of neutron, proton, electron, and nucleus. Neutron and proton sticks together at the nucleus while being surrounded by electron, which spins around the orbit. Atoms, the smallest unit of ordinary matter that forms a chemical element. Every solid, liquid, gas, and plasma is composed of neutral or ionized atoms. Here are examples of atoms. We have iron, hydrogen, and gallium. Parts of the atom. The first one, we have the proton. It's a positively charged particle. The second one, we have electron, a negatively charged particle. The third one, neutron, a positively charged positive charge carrier. We have nucleus, the central core. We have orbit, represents as energy level, which acts as a pathway for electrons to spin around the nucleus. And the orbital is a region around the nucleus which has the highest probability for an electron to exist. Let's go to some history of atom. At first, we have Democritus. He says that an atom is a tiny invisible particle called atomos. And we have John Dalton, who says that an atom is a solid block of indestructible positive sphere. He took this model out of a billiard ball, so let's see some examples of it. You can see the blue ball and the gray ball. So John Dalton assumed that atoms has this kind of appearance. Moving to the third one, we have J.J. Thomson, who discovered electron using the cathode ray tube experiment. He concluded that an atom is a plum pudding where the bread is the positively charged sphere, while the raisins are like the electrons embedded of the sphere. Here's a picture of the cathode ray tube. At the left, we have the cathode, anode, grounded, going to the cathode rays and the electric field, which will determine whether it has an electron or proton. And then we have the cathode rays, the accents of an electric field. At the end, we have the scaling and the phosphorescent coating. So in the picture, you can see that the cathode ray moves up on the electric field, being attracted to the proton, which means it has electron. Since electron is attracted to proton, so it goes up, it means that there is electron. Number 4, we have Ernest Rutherford. Discovery of proton, discovery of nucleus, discovered that atom is mostly empty space, used the gold experiment or alpha scattering experiment. So here's the picture of the gold foil experiment. There's the radiation source. He used radium for this, and then it radiates the alpha particles to the gold foil and to the fluorescent screen. The fifth, we have Niels Bohr, which is the discoverer of energy called orbits. It can be called as quanta or shell. So here's the example of what he discovered. They have electron orbits, they have the electron, they have the neutron. So the circles around it is called the electron orbits, which what he discovered. We have the sixth, James Chadwick, discovery of neutron from beryllium atom using the cathode ray tube. So in this case, it's actually similar to J.J. Thomson's cathode ray tube, but the electric field, but the cathode ray, it doesn't move from where it does. So it actually stays in the middle. It doesn't go to the positive, it doesn't go to the negative, so it stays at the middle, which means it's not attracted to any of it. So it concludes that electron is a non-charged particle. Here's an example of the atom symbol. As you can see, we have the atomic number, element symbol, and element name, and also molar mass. At the top left, we have atomic number, which is 12. Now the element symbol is carbon. We use C for the element symbol. And the element name is carbon, while the molar mass is below it. Some facts about atoms. They have the same number of electrons and protons. And also the atomic mass of the atom is the total number of protons and neutrons. The atomic number of an atom is the number of protons. The atom's mass is 99% of the nucleus and 1% of the electron. So let's do some calculations of this. Remember, protons are equals to electrons and atomic mass is equals to proton added by neutron. Let's go to number 1. An atom has an atomic mass of 14. It has 7 neutrons. What is this atom? So to answer it, we have the atomic mass, which is neutron plus proton. The symbol is A. So we have the proton equals to 7 by finding it like this. 14 equals 7 plus P. P is the proton. So we move the 7 to the left side so that it minus, and then P becomes 7. So we have 7 protons. Protons is also equivalent to the atomic symbol, to the atomic number. So if it has 7 protons, then the number is also 7, which is nitrogen. Number 2, we have a silicon atom has a molar mass of 28. It has 14 neutrons. Calculate the electron and protons. Given A equals 28 and equals 14. So we have the atomic mass of 28 and we have neutrons of 14. To answer this, we need the proton. So the proton is equals to atomic mass minus the neutron. So we have 28 minus 14, which is 14. Since protons and electrons have the same amount, so both of them are 14. Number 3, we have an atom has 20 neutrons and 20 electrons. Calculate its molar mass and identify which atom this is. So the given we have neutron, which is 20, electron, which is 20. To answer this, we have the atomic mass, which is neutron plus proton. Since electron is equals to proton, so proton is also 20. So atomic mass is 20 neutrons plus 20 protons, which is 40. Now, the atom that has this molar mass is a calcium. Number 4, we have an atom has a proton of 3x minus 4 and electron of 2x. Find the actual amount of both proton and electron and indicate what atom it is. To answer this, since proton is equals to electron, hence 3x minus 4, which is the proton, equals to 2x, which is the electron. We move the 2x to the left side and move the 4 to the right side. We get 3x minus 2x equals 4. Leaving it into x equals 4. So we have proton equals to 3 times 4 minus 4. So we get 12 minus 4 equals 8. So the atom that has the atomic number of 8 is oxygen. 5. PD or Palladium has an atomic number of 2x plus 46. It has 4x minus 2 electrons and has a molar mass of 106. Find the neutron. So we have the given, the Z equals to 46, E equals 4x minus 2, and A equals 106. Z is called the atomic number. Z is the symbol. So, since E equals P equals Z, hence, the atomic number is equals to the electron. So we're going to put it by substituting it. So we get 4x minus 2 equals 2x plus 46. We get 2x minus 2x equals to 48, and then x equals 24. To find the electron, put the 24 into the x. So we get electron equals 2 times 24 minus 2, so we get 48 minus 2 equals to 46. Remember that electron has the same amount as proton, so proton is also 46. Following the arrow to the right side, we have neutron equals atomic mass minus proton, so it equals to 106 minus 46, so we have 16 neutrons. Let's see a bit of the periodic table. So we have the periodic table over here. We have the alkali metal, we have the alkaline metal, transition metal, basic metal, semi-metal, and non-metal. We have halogen, noble gas, lanthanide, and the actinide series. Arrangement of the elements of the periodic tables. We have 1A equals to alkali metals, which is on the left side on the periodic table. You can see hydrogen, lithium, and you can see sodium, potassium, rubidium, cesium, and francium. And then we have 2A, which is alkaline earth metals. It's on the second left column, which is starting from beryllium down to radium. And then we have 3A, which is the boron group. So it starts from B, which is at the 6th from the right, the green one. So we get boron, aluminium, gallium, and then so on. Now we have 4A, which is the carbon group. So let's see the periodic table. We have the carbon group, which is at 4A, 5th from the right. It starts from C to silicon, germanium, tin, lead, and so on. And then we have the 5A, the nitrogen group, which starts from 4 from the right, the N, nitrogen to phosphorus, and then to so on. And also we have the chalcogen group, the 6A. So it's from oxygen, 3rd from the right, to sulfur, and down towards. For 7A we have the halogen group. It starts from fluorine, which is 2nd from the right, to chlorine, bromine, iodine, astatine, and more of them. And lastly, we have 8A, inert gases or noble gases. It's the right one. We have helium, we have neon, we have argon, we have krypton, xenon, radon, and organism. Fun fact, organism was found not recently, it was found recently. So it was added just recently. It used to be only 117 atoms, but now they add organism, which is the 118. And now we have 3B to 7B. They are the early transition metals. And we have the 8B to 2B. They are late transition metals. Lactinide and actinide series. Inner transition metals. Period or series is the horizontal row in the periodic table. We have the group or family is the vertical column in the periodic table. Thank you.